Hello students, welcome to ASN Chemistry. Today class I am going to teach you trick to remember all named reactions from haloalkanes and haloarenes. These 10 named reactions are very important. What are those? Wurtz-Fittig, Schwarz-Finkelstein, Sandmeyer-Gutterman, Friedel-Crafts alkylation, Friedel-Crafts acylation and Dow's process. Watch complete video. Definitely you will get benefit from this. First, Wurtz reaction, Fittig reaction, Wurtz-Fittig reaction. Here we have to compare and learn these three reactions. Okay now. Remember, in Wurtz reaction, alkyl halide is reactant. Fittig reaction, aryl halide is reactant. Wurtz-Fittig reaction, one alkyl halide, one aryl halide is reactant. What are the common in all three named reactions? Sodium and dry ether is common. All three named reactions, sodium and dry ether is common. First, let us start Wurtz reaction. In Wurtz reaction, what is the reactant? Look at this. In Wurtz reaction, alkyl halide is there. And what are the common? Sodium and dry ether. Look at this. Here, 2 moles of alkyl halide react with 2 moles of sodium in presence of dry ether. In presence of dry ether. Okay. Next, here Fittig reaction. Fittig reaction, what we have to take? Look at this. Aryl halide we have to take common sodium and dry ether. So in Fittig reaction, you can take 2 moles of aryl halide plus 2 moles of sodium and in presence of dry ether. In presence of dry ether. Okay now. Next, Wurtz-Fittig reaction. Here Fittig, we have to take aryl halide. Take aryl halide. And Wurtz reaction, you can take alkyl halide. What are the common? Yes, sodium and dry ether is common. Sodium and dry ether, these are the common. Okay, now let us write the products for all three reactions. First, in case of Wurtz reaction, look at this. Here, two alkyl groups combined to produce alkane. And what is the remaining? 2 sodiums and 2 halogens, 2 moles of NaX. Clear. Next, Fittig reaction. 2 aryl groups, 2 phenyl groups joined together. Look at this. This is one phenyl group. This is one phenyl group. To give diphenyl, same as before, to give remaining 2 moles of NaX. Clear. Next, Wurtz reaction. In Wurtz reaction, one aryl group, one alkyl group combined to give alkyl arene or alkyl benzene will form. What is the remaining? 2 sodiums, 2 halogens to give 2 moles of NaX. Got it right? Let us write examples for all three named reactions. First, Wurtz reaction. Wurtz reaction example, look at this. CH3Cl, methyl chloride, okay. 2 moles of methyl chloride react with 2 moles of sodium in presence of dry ether. In presence of dry ether to give 2 methyl groups joined together, right? So, CH3CH3, ethane will form. What is the remaining? 2 moles of sodium chloride. Next, Fittig reaction. For this example, okay, you can take chlorobenzene, 2 moles, react with 2 moles of sodium, okay, in presence of dry ether. In presence of dry ethers, here what happens? 2 aryl groups join together. This is one phenyl, this is one phenyl. Diphenyl will form to produce 2 moles of NaCl. While writing, write benzene properly, hexagon, okay. And next, Wurtz-Fittig reaction. So first you can take chlorobenzene or bromobenzene, and next CH3Cl, 2 moles of sodium in presence of dry ether. In presence of dry ether to give methyl benzene, also called as toluene. What is the remaining? 2 moles of NaCl. Clear. Yes, this is the first trick to remember Wood's reaction, Fittig reaction and Wood's Fittig reaction. Got it right? You can write these three named reactions in your class notes. Next two reactions, Schwarz reaction, Finkelstein reaction. Both are halogen exchange reaction. Let us compare and learn these two reactions. Look at this. First remember these points. Schwarz reaction, alkyl fluoride is prepared. Finkelstein reaction, alkyl iodide is prepared. Here how do you remember? These are the halogens, fluorine, chlorine, bromine, iodine. Okay. Schwarz have less alphabets, right? So small halogen. Finkelstein have more alphabets, so large halogen. You can remember. Okay. Now next reagent. Schwarz reaction, RF we have to prepare. So AgF you have to take. Okay. RF we have to prepare. So AgF you can take. Next Finkelstein, Ri you have to prepare. You can take NaI. NaI. You got it right? So let us start the reaction. Look at this. First Schwarz reaction. Here first we have to take alkyl halide. Here halogen can be either chlorine or bromine. Chlorine or bromine. Even Finkelstein also same. Alkyl halide. What is the halogen here? Either chlorine or bromine. Chlorine or bromine. Okay. Next. Schwarz reaction we have to prepare alkyl fluoride. What we have to prepare? Alkyl fluoride. That's why you can take AgF. AgF. It looks like KGF, right? AgF. Okay. So now let us write the reaction. So in this reaction, here halogen is replaced by either chlorine or bromine, fluorine. So you will get RF, alkyl fluoride, and remaining is AgX. AgX. Okay, next let us come to the Finkelstein reaction. In Finkelstein reaction, what we have to take? Here we have to prepare alkyl iodide, right? So reagent is sodium iodide. Sodium iodide and solvent dry acetone. Dry acetone. So here also exchange reaction. Look at this. Here X is replaced by iodine. Then what will you get? Ri. Alkyl iodide you will get. Remaining is NaX. NaX. Let us take one example. Look at this. Here one simple example I will take. CH3Cl methyl chloride react with what is the reagent? AgF. AgF. So here chlorine is replaced by fluorine. We will get CH3F methyl fluoride. What is the remaining? Right, AgCl. AgCl. Methyl fluoride is formed. Okay, next Finkelstein reaction. Let us take one example for this. CH3Cl you can take, or CH3Br. CH3Cl plus NaI. Sodium iodide. What is the solvent? Acetone. Take acetone. So here what happens? Chlorine is replaced by iodine. So we will get CH3I methyl iodide plus remaining is NaCl. Once again I will repeat. See here, Schwarz reaction, alkyl fluoride we have to prepare, reagent is AgF. Finkelstein reaction, alkyl iodide we have to prepare, reagent is sodium iodide. Got it. And remember one more thing, in Schwarz reaction we can take not only AgF, these all metal fluorides we can take. Got it right? So write in our class notes and practice this. Next, let us compare and learn Sandmeyer reaction, Gutterman reaction. Both reactions almost similar. Look at this. In both Sandmeyer and Gutterman reaction, reactant is same. Benzene N2 plus Cl minus. Name benzene diazonium chloride. Product also same. Chlorobenzene, bromobenzene, byproduct nitrogen. Okay. Reactant products are same. Got it right? And next, what is the reagent? In Sandmeyer reaction, cuprous chloride HCl or cuprous bromide HBr we take. Gutterman reaction, copper powder HCl, copper powder HBr. The reagents also you can observe almost similar. HCl common, HBr common. Only thing is cuprous chloride is replaced by copper powder here. cuprous bromide is replaced by copper powder here. Got it, right? So let us start the reactions. See, first Sandmeyer reaction. Benzene diazonium chloride. You can remember on benzene ring N2 plus Cl minus is there. Benzene diazonium chloride. What is the reagent I told? Sandmeyer reaction. Cuprous chloride Cu2 Cl2 HCl. Right. What is the one more reagent? Cuprous bromide. Here chlorine is both the compounds. Chlorine is replaced by bromine. Look at this. Cu2 Br2 cuprous bromide HBr. Then what is the product? So take benzene ring, both the things. Take benzene ring, and here first case, whenever you take cuprous chloride and HCl, chlorine is introduced. Whenever you take cuprous bromide HBr, bromine is introduced. So chlorobenzene and bromobenzene are formed. And what are the byproducts? Byproducts are nitrogen gas. Both the cases nitrogen gas. Got it, right? Now let us take Gutterman reaction. In Gutterman reaction, what I told? Here same to same, but here cuprous halides are replaced by copper powder. So first copper powder HCl, next copper powder HBr, Now I told, right, products are same, reactant products are same in Gutterman and Sandmeyer reaction, right? So take benzene ring. Okay, here first case chlorine is introduced because HCl is there. Second case HBr, bromine is introduced. Chlorobenzene and bromobenzene are formed. And byproducts nitrogen plus nitrogen. Got it, right? Now you can write both named reactions in your class notes and practice. Next, let us compare and learn Friedel-Crafts alkylation and Friedel-Crafts acylation of chlorobenzene. Before to that, learn few basics. Here chlorine, bromine, OCH3, OH, NH2. These are called as ortho-para directing group. In presence of these groups, electrophile attack at ortho position and para position. Number 2. For example, benzene have some group. Let us take as a X. Second position, sixth position is called as ortho position. Third position, fifth position is called as meta position. Next one is para position. You can observe here ortho meta para. Next, benzene with CH3 called as toluene. Benzene with COCH3 called as acetophenone. Next, in Friedel-Crafts alkylation, reagent is alkyl halide. Acylation is acyl halide. Example, methyl chloride and acetyl chloride. And both the reactions, common thing is anhydrous AlCl3. It is Lewis acid. Got it, right? So let us start the reactions. First, Friedel-Crafts alkylation of chlorobenzene. So take chlorobenzene. What is chlorobenzene? Take benzene ring and it has chlorine. It is called as chlorobenzene. So alkylation, simple alkyl halide I will take CH3Cl. Any alkyl halide we can take. I am taking CH3Cl, methyl chloride. What is the catalyst we have to take? Look at this. Anhydrous AlCl3, which is Lewis acid. So you can take anhydrous AlCl3. Anhydrous AlCl3, which is Lewis acid. Okay, now. So now let us take chlorobenzene plus chlorobenzene. Okay, so here CH3Cl split into CH3 plus and Cl minus, and here CH3 plus is the electrophile, right? The CH3 plus will attack it. Just before I told you, right, one thing, what I told, chlorine is ortho-para directing group. It attack at ortho position and para position. So the CH3 will attack at para position, that is fourth position, and CH3 attack at ortho position, that is second position. So here without chlorine, name of the compound is toluene. So 4-chlorotoluene. Here without chlorine, it is called as toluene. So second position chlorine, right? 2-chlorotoluene. In this, first one is the major product, second one is the minor product. Okay, and next let us take Friedel-Crafts acylation. So what is the reactant? Same. Take chlorobenzene plus acylation. Acylation, what we have to take? Acyl chloride we have to take. For example, acetyl chloride. CH3COCl. What is the catalyst? Catalyst is same, both the cases, anhydrous AlCl3. Okay, anhydrous AlCl3. Anhydrous AlCl3. So first you can take chlorobenzene plus chlorobenzene. Okay, so in this case CH3CO plus split into CH3CO plus and Cl minus. Okay, CH3CO plus and Cl minus. The CO plus CH3 is the electrophile. It attack at para position COCH3 para position. COCH3, here also COCH3. Don't forget, you should write COCH3 but not CH3CO. If chlorine is not there, just before I told you, right, it is called acetophenone. So fourth position chlorine 4-chloroacetophenone, second position chlorine 2-chloroacetophenone. Okay, once again, in alkylation, here look, observe here, CH3 plus is electrophile, acylation, CH3CO plus. Easily you remember, this is CH3, this is CH3CO. In first reaction, CH3 attack at para position or the position. Second reaction, COCH3 attack at para position and or the position. Got it, right? Write in our class notes and practice. Next reaction, Dow's process. Here I will give you one small trick how to remember. You can assume one student is there. He is studying BA, Bachelor of Arts. Okay, he got 300 marks out of 350. He got 300 marks out of 350. Okay, so here B for base. What is the familiar base? NaOH. A for acid. What is the familiar acid? HCl. These two are reagents. And here 300 atm. Pressure is 300 atm. Temperature is 350 degrees Celsius. Okay, now let us write the reaction. Look at this. Here reactant is chlorobenzene. First reagent what? NaOH, right? First reagent. So react with NaOH. Here Cl is replaced by ONA. It's called as sodium phenoxide. Okay, and what is the temperature and pressure I given? 300 atm pressure and 350 degrees Celsius. Okay, now next, what is the second reagent? Second reagent is HCl. Okay, now it react with HCl. Now here sodium is replaced by hydrogen, H plus. Okay, so OH. Got it, right? Now what name of the compound is phenol. Once again, chlorine react with NaOH. First of all, chlorine is replaced by ONA. Second case, react with HCl, Na plus replaced by H plus. You will get the phenol. I hope you like this video. Please subscribe our channel and share this video to your friends and classmates so they can also get benefit from this. Okay, see you in next video. Bye bye.